Our presenter will be Grant Seward. Grant is a data scientist turned developer with over a decade of experience building data products at companies including Capital One and Walmart. The title of the talk is User-Facing Real-Time Analytics Using Apache Pinot. Oh, sorry, that was the other talk in the other stage. The talk is Operationalize the Data Catalog. Sorry about that. Grant, the stage is yours.
Hey, thank you. And thank you to everybody for joining my talk today. Good afternoon to everybody, and good morning and good evening to those coming from around the world. Just to give a little more introduction about myself as we start things off here. My name is Grant. I am currently a founding engineer with Stemma. I'm also a maintainer of Amaton, the leading open source data catalog, and I previously founded Tree Schema, the first fully product-led data catalog. I've been building data products for a little bit over a decade now, and I really enjoy helping others get the most value out of their data. So what does it mean to operationalize the data catalog? Simply put, this means to put the data catalog into the critical path for some business processing. In order to provide the full context on why the catalog should be used for operational use cases, I'll touch on the de facto way that they are used today and what challenges this leads to. Historically, data catalogs have been used asynchronously. As depicted here, business critical processes, for example, data pipelines or CICD pipelines, use databases in order to persist data, and they run on top of workflow engines or that orchestrate the tasks that drive the underlying business processes. Metadata from these databases, workflow engines, dashboards, etc., are then ingested into the catalog via some push or pull mechanism, where they are then structured, indexed, and made available for users to query and to view. By and large, the data catalog has not been used for operational use cases that drive the business directly. Since the data catalog is one level removed from the immediate infrastructure that supports business critical processes, you may have downtime within your catalog, and with the exception of a few disgruntled analysts, it's likely you won't really impact your reports, workflows, code deploys, or pipelines. The asynchronous nature of the typical catalog means that the value derived from the data catalog will be limited to these asynchronous use cases. So this is a pretty big shortcoming that data catalogs have today, and we'll now explore a few places where this can really become a limiting factor for the data catalog as it continues to grow and expand within your data ecosystem. This first point is really the most important in my mind. Data catalogs have become purely reactionary software. We can see this with the tried and true example that everyone is likely familiar with. To start off, you may have a dashboard that is working, your VP goes to check it each morning, and they understand how their team is performing. At some point later on, someone in the company changes a table or a pipeline. Unbeknownst to that person making the change, there's quite a few other tables that are downstream that are going to break once their code ships. The next morning, you receive an email from the VP saying that the dashboard is no longer working. And in order to find the root cause, you log into the catalog or into GitHub, and you find the dashboard and you see that it is built from one table in a warehouse. You then use lineage within the catalog to discover that this table has two upstream tables. As you continue your research by looking into those two tables, you discover that a critical column was dropped. This is the same change that was made yesterday. The data catalog clearly had all the information required to determine if there was going to be an impact on your VP's report prior to when the column was removed. What we want is for the data catalog to become a proactive piece of software, preemptively identifying and alerting on issues before they occur. The second point here is that the value you receive from your data catalog is completely derived from the number of users. At first glance, this really is a great thing, and it's to be expected. The larger your organization, the more difficult it becomes to communicate effectively, and therefore the more data a company has, the more value a catalog provides by enabling discovery, reducing time to market, reducing duplicative tables or metrics, and so forth. So why is this a shortcoming? Well, the value from a data catalog should scale with your data, and in particular, your metadata, in addition to the number of users that you have. Take a look at this example graph that depicts the hypothetical growth of a company, a product, or a new line of business. At some point, the velocity for which you add new data will very likely increase at a rate much faster than the rate at which new team members are being added. So let's also take a moment here to reconsider the prior example. We talked through the steps to determine the root cause for the dashboard issue that your VP had. Let's try and think about what the true impact here would be to the business. You spent time on unplanned work, meaning lost time from the stories in your current sprint. You need to spend more time to potentially manually recreate or fix the data or to run backfills. As much effort and implementation that people put into backfills, they always seem to be a pretty arduous and difficult task. And your VP does not have the information required to potentially make a critical decision on that particular day. These can have real monetary impacts to your company and things that we should, again, try to include in the way that we derive value. The more data that you have, the more likely you are to have these issues within your company on a more frequent basis. Given this, we should expect that the value we derive from the catalog should scale with the amount of metadata that it contains, as well as the number of users. So the way in which you can plug your data catalog into an operational process is really only limited by creativity. I'll talk about what I believe are some of the more important and practical ways that we've done in the past. The first is going to be one of my personal favorites in how we integrate the data catalog into the CICD pipeline. The CICD pipeline is this really interesting inflection point between new code and old code, just as importantly between new data and old data. Data catalogs are often integrated into CI/CD pipelines today. When metadata changes, those events are sent to the data catalog from the deployment process. But this approach is more about creating that bi-directional interaction and allowing the catalog to make a decision whether or not a change should be allowed based off of the potential impact to other data assets. We know that the data catalog has the knowledge about the shape and semantics of the data that already exists. The capability we want to enable here, again, is to give the catalog insight into what the shape and semantics of the data will be in its future state. By allowing the catalog to have knowledge of the before and after, it opens up the door to be able to ask some really interesting questions. Will removing this field have a business critical impact? Will this change in my Avro file to include not null constraints lead to records not being inserted into the database where not null is not allowed? Before I drop a table, can I be alerted if any dashboard built on top of this table has been used in the past 3 months? The ability to gain insights here are really limitless, but having that before and after view of the data is the really critical aspect. The beautiful part about all of these questions is that they can be answered purely with metadata and without looking at the underlying data itself. Again, the key here is about the bi-directional communication between the CI/CD process and the data catalog, and not simply emitting the events for data catalogs to consume asynchronously. When you enable this bi-directional communication, you become proactive. You're discovering issues in your data before they occur. And the data catalog becomes another validation step within your code quality and data quality suites. One of my personal favorite use cases for this is where the data catalog is integrated into the CICD process, and it proactively is identifying lineage before the change to the underlying ELT process occurs. In general, automatically capturing lineage requires a relatively large effort to implement. And while there are providers that enable plug and play lineage capture from SQL logs, it remains a capability far too companies have been able to invest in. Unfortunately, something that I see far too often for companies that do rely on SQL log parsing is that it's their only way of capturing lineage. And I'm here to say, if you are only capturing lineage from SQL logs, you're doing it wrong. SQL logs are great for bootstrapping lineage and augmenting your lineage data capture, but as seen in the prior example with the engineer who broke the downstream dashboard, it is reactive and unable to prevent breaking changes. When you only rely on SQL logs for your lineage, you are, in effect, working in append only mode, where SQL parsers can easily detect a new insert into, select from statement that has been executed. However, these approaches really struggle to know when something has changed or been removed. Even tracking DDL changes will not fully answer these types of questions. Let's look at a more robust approach using a data catalog that leverages SQL logs to augment its lineage, but not be the sole source. This high-level process architecture describes what a proactive approach and a reactive approach combined together would look like. It's really a tale of two sides of the same coin. On the left, we utilize the approach where we read SQL logs from the warehouse and BI tools on a set cadence. Those logs are then parsed and the lineage is saved within the lineage database. Using this approach, we get a really nice picture of what is actually happening within our data ecosystem. On the right side, we're exposing an API for bidirectional communication with the CICD process. And there are two important aspects to note. The first should be somewhat obvious. We're trying to utilize the existing parsing logic and lineage database information. Following dry principles, there's actually not much we need to do with the data catalog to build this integration, since we already have the query parser integrated into the catalog. We can simply expose some form of REST API or other synchronous response and be able to provide this ability to hook in from our CI/CD pipeline. The second item is slightly more nuanced. This box that says validate SQL refers to how we determine the scope of our SQL to verify whether or not there is a breaking change. Moving from a reactive to proactive lineage approach can be a pretty major undertaking with many pitfalls. One of the biggest challenges is to determine what is a breaking change. And so let's dig into this a little bit more. You can really only answer the question, what is a breaking change, when you are able to see every downstream place where your table or column is used. There are many, many different flavors to this use case, but I'll set up a basic pipeline for how data flows between just 3 tables to demonstrate the problem. So here, we have 2 SQL scripts that run within our ELT process. Script 1 inserts columns A and B from table 1 into table 2, and script 2 inserts column A into table 3 from table 2. The change we're going to make here is that we will no longer be inserting column A from table 1 into table 2. And we'll also eventually be removing the insert from table 2 and table 3. Let's look what happens when we try to validate the change to our pipeline by verifying each SQL statement in isolation. When we check if the change is being made between table 1 and table 2 is a breaking change, our lineage system should see that it does impact a downstream process and therefore should be considered breaking. Again, because we're providing these SQL statements in isolation, if we provide the table 1 to table 2 insert first, it's not going to be aware that table 2 to table 3 has been removed. However, if we scope the change to include the entire set of changes to our pipeline and really the full state of our pipeline, the catalog should see that this new state is not breaking, since all downstream dependencies are also being removed. Therefore, this should be allowed. All of this is to say, when you proactively validate your SQL changes, it is important to choose the right scope when applying validations. Simply validating a single SQL statement at a time will not suffice. When done right, proactive lineage validation should be rather simple. Implementations can be as little as 1 or 2 steps, assuming that your catalog has the ability to verify your lineage. With any other implementation or hook into your pipeline, you just need a new check. And so what I've shown here is something that should feel relatively familiar to everyone. This is just a GitHub action using Python. And then the second item is going to be a script that we use is actually going to validate your code using the SQL within your repo. And so again, the thought here is to push as much of this logic into your catalog where possible and allow simple consumption of this information and this data by different clients that operate in isolation. There's a lot of approaches that can be taken here in terms of how to manage your code and your SQL across different teams and organizations. And so this is certainly something that needs to be addressed individually, but the ability to provide all of your code within a pipeline that's going to have a singular impact should be provided to the catalog at once. The second use case I'll talk through is for how to operationalize the data catalog in order to have it integrate directly into your data pipelines. In particular, we'll look at how to dynamically apply workflows by taking actions off of asset classifications or tags within your catalog. One common way to classify assets within a data catalog is via tagging. As you're likely aware, tags are just attributes that can easily be assigned to different data assets. They can be assigned to a field, a table, a pipeline, a database, or really anything else within the catalog. Tags are great for answering questions such as, give me a list of all tables that have an email address in them. And there are essentially two ways that tags can be added to the catalog. The first is where the catalog profiles data in your warehouse, runs the data profiling output through a set of rules or an engine or a model, and it creates tags based off of the data that it has processed. This is fantastic for data that is easily identifiable, such as phone numbers, addresses, and credit card numbers. The second is user-provided input, where a user simply logs into the catalog and manually tags the asset, or some other developer manually encodes them in the code, and this gets pushed or pulled into the catalog. This second approach is particularly useful for the use case where we're dynamically taking action off of information within the catalog. What we'll see shortly is that this allows users, in particular non-technical users, to tag assets in a user-friendly way that will propagate into the data pipeline with no additional development effort. And this is really the biggest thing that we're aiming for here. How can we maximize developer utilization by allowing them to reuse their code on a second tier without having to necessarily make changes to the pipeline whenever some business user or finance person comes and says that they need to make a change based off of some external business rule. One of the best use cases for this is handling PII data. So handling PII data within your ecosystem, and in particular within the warehouse where users are querying data, is often a challenging task. Your company likely has security requirements around the handling of PII data that requires it to be obfuscated or hashed, or perhaps PII data needs to be put into a completely separate physical database where only a limited number of users can access it. This challenge is compounded when you consider that the requirements around handling PII often change based off of internal rules or external regulations. You may receive notice that storing the last 4 digits of a credit card number are no longer allowed, or that the combination of zip code and date of birth cannot be kept in the same tables. This is a great use case for dynamically generating workflows based off of asset tags for 2 reasons. One, the functions being applied to PII data are likely going to be simple. We are just going to hash the fields to keep them unique and deterministic. And 2, the people who will determine what data is PII are going to be non-technical business owners or the legal team in this example. So in this example, we'll be following the ELT paradigm to insert data from one table into another table. dbt is by far the most popular tool that we use for building pipelines in the warehouses. And I'll show how we've implemented this use case using some of the tools provided by dbt. The how-to for this process is actually rather simple. Each table or each column that we want to tag, we're simply going to check the catalog for the different tags that it has, and then apply any required updates to our SQL based on the tags, and then we're just going to run the SQL. As for how we make DBT aware of the tags from our warehouse, DBT documentation suggests that all pipeline inputs, where possible, already exist within the warehouse as a view or a table. So it's important to note that we're already exporting our entire data catalog into the warehouse where it can be used for these pipelines. Everything else that I will be showing here is just going to be leveraging the existing DBT tools and capabilities that are provided. So here is a working example of a macro that returns all of the existing fields in a table that contain a given tag. A lot of this is defined in the DBT macro documentation, so I'll just touch on a few of the key points. As we define the inputs for our function, we're just going to ask for the name of the table and the tag. And we'll see shortly on that this allows us to get all PII tags for a given table. We're then going to inject those predefined tags into a query, and we will be able to return a set of tags again for this table. And then finally, we're going to use DBT functions to load these into a list, which will be returned. This function in particular is great because it provides a lot of reusability across the data pipeline ecosystem, and a lot of different use cases can leverage this regardless of whether or not they're directly associated to PII tagging. The second step here, where the previous macro showed how to get all the columns that are tagged with a specific value, this macro applies the business logic required to obfuscate our PII fields. Again, the first thing we're doing is we're calling the prior macro. This gets the PII columns for the table. Second, we're using DBT macros once again to get a list of all fields that exist within this table. And third, and finally, we create the field to be returned. This will resolve to the normal column name if the column is not tagged as PII, and conversely, the column will be hashed if this is a PII field. And it will be aliased so that our output column for the users will remain the same regardless. Now that the utility functions are in place, you can wrap your tables with your macro. Once wrapped, the output of your models and the target compile directory will contain your auto-obfuscated tables. As seen here, we're doing a pretty basic transformation, and we're just hashing a single field. But there's a bunch of other use cases where this may be valuable as well. One of which may be if you have state of your tables, for instance, if you move from development into production and eventually deprecated, you may decide to tag your data assets with some life cycle annotation, and to use this to drive the different schema or potentially even a different database to put your data into. And again, the uses for how you can leverage this asset tagging within your data warehouse are really only limited by creativity. So what makes a data pipeline a good candidate for integrating with data catalog? Handling of PII data within your ecosystem, and in particular within the warehouse, so there's 2 points here that we want to cover for what is going to be a good candidate with integrating within the data catalog. The first is that we want to have a very simple and deterministic action that can be taken. As we saw with the PII data, this was hashing a field. We could have this be dynamically inserting a new column. Maybe we have a particular timestamp column that should be applied to all tables that denotes event timestamp versus created or received timestamp. We could also place this table into different databases. And the second thing is that we would expect that the inputs here into this pipeline should be changed independently of the pipeline. Again, as we saw, PII classification comes from a legal team. They are going to be independent of the pipeline. And in addition, as we think about changing the life cycle of a particular table from development to certified to deprecated, this would also be an external decision made outside of the pipeline. And with that, that is all from me. So again, I thank you for joining me in this talk today, and I'm happy to take time for some Q&A.
Thank you very much for this great talk, and I'm happy to report that we do have questions. Let's just get down to it. So the first one goes like this. I hope I'll be able to pronounce all those technical words properly. So does the tool work with NoSQL or NoSQL databases like MongoDB or DynamoDB?
Yeah, it's a good question. And I'm assuming the question here is around the DBT integration.
I would assume so as well. It's not my question, but probably you're right in assuming so.
Yeah, I actually am not super familiar with DBT and NoSQL. I would have to refer to the DBT team. So unfortunately, I don't know that I'm the best person to give an answer there.
All right, all right. In the meantime, there will be still time for a couple more questions. So if you do have questions, here's the time to ask them. But there's one more that already arrived. Can companies self-host the data catalog?
Yeah, totally. Amundsen is actually one of the most popular self-hosted data catalogs. Excuse me, there's a rich community of several hundred companies on the Slack channel. I would highly recommend everybody going to visit the Amundsen GitHub page. You can just Google Amundsen GitHub, join the Slack community. There's a bunch of support. I'm in there personally as well, in addition to a bunch of other members from Stemma. Yeah, it certainly is an easy thing to do, relatively easy thing to do. One of the big challenges that we see with a lot of companies is not necessarily the actual hosting of the platform itself, but how do you build the culture within your organization to be able to maintain the assets and maintain the descriptions and to keep your data catalog up to date? There's only so much that a data catalog can do to augment and support that process. It's really a cultural change and how you think about promoting data within your organization that are more key aspects to having a successful data catalog implementation. All
right, thank you very much. There's still time, so if you have the question, send it. And in the meantime, let me just point out how some people, or one person said hi to your dogs, which were very cute in the background, and a lot of people gave a thumbs up for that, and there you go. There's one of them. So
thank you.
That was a very good extra. And good, we have a new question. Great, great, great. Oh, actually, we have two more questions. Perfect. Here's the first one. What's the next big thing in the life of Stemma Amundsen?
Oh, good question. Man, this is such a broad question. I guess I'll talk in terms of Amundsen. That's a little more open to the public. There's a lot going on right now in terms of how we're going to be revamping some of the search work within Amundsen. The way that we think about search is changing a little bit. In particular, how do we allow much more complex questions to be asked? So currently, as an example, a user may log in and you may just search for a particular column, user ID or status or customer, something like that. And you'll get a list of tables and columns. But what we really want to think about is like, how are users expressing questions about other sorts of information within their data ecosystem, in particular metrics. And so you might have a question, how do I measure ROI, or how do I measure MAU for this particular product? And so a lot of the search revamp is going to be targeted towards allowing Amundsen in particular to have a much more robust way of answering these questions. On the technical side, it includes moving away from some of the different proxies that we have in the backend. And for context, Amundsen currently supports search proxies for Elasticsearch, Apache Atlas, and you can also implement your own proxies there as well. And we're looking to consolidate this to just be Elasticsearch, and in particular, the newest, or not the newest, but Elasticsearch 7. And so by consolidating these, it allows us to have a smaller breadth of capabilities, but also a much deeper set of capabilities within that. And so moving away from Atlas in particular allows us to build more compatibility within Amundsen that Atlas could not previously handle.
All right, great. Here comes the next one. This all looks great, but I don't see how this can be practically scalable for very complex organizations like investment banks. What are your recommendations for implementation in such cases?
Yeah, it's a very good question. I think that this question would really extend to data pipelines in general, at least in my opinion. Managing data pipelines across large organizations and dependencies in particular is often a very challenging thing to do. One of the ways that I like to think about it personally is how do you allow teams to be independent and to fully solve use cases on their own? And in addition, make that information available and usable by downstream teams as well, while having that very consistent and almost guaranteed interface of what your data looks like. And so a lot of times, in the warehouse in particular, your interface is that definition of a table. And so for me, thinking about how, in particular, the DBT processing with the data catalog and the tags can be used within the warehouse comes down to ensuring that you have the proper interface for your tables available. And if you have ownership of a table and you're able to manage that within your team, then as you're making changes to that should follow very, very similar practices to how you're making changes to APIs, for example, and how other teams are consuming them. And so what we're trying to do is to think about this as more of a traditional developer practice than a singular one-off data practice, and to really bring visibility across pipelines by allowing Lineage to give that full breadth of if you break something here or if you make a change here, we can immediately tell you what the impact is going to be. I hope that answered the question.
All right, thank you very much. And the final question goes like this. Are there methods to handle Lineage when pipeline is implemented using multiple scripting languages? I mean, not only SQL.
Yeah, that's a very good question. And I think that even when you have SQL, it doesn't always get all of the lineage. Like SQL parsing is not absolutely perfect. The way that we think about this is providing instrumentation, and that instrumentation is typically just a REST endpoint. And so you have the ability to annotate any of your pipelines or your workflows with points where you can say, look, I know that this is a complex in-memory pandas transformation, for example, and you can manually provide those inputs and output for what your lineage is going to be. It's, in my opinion, like a really robust and really good thing for teams to do, because it provides you that more granular ability to manage what your lineage is. And on top of that, you can start to check in the changes to your lineage into GitHub as well. And you get this really nice version controlled, source controlled view into what your lineage changes have been over time, which is something that's a little bit more difficult to do even within the catalog when it's automatically capturing lineage from the SQL logs.
All right. Thank you very much. And that was our final question.